Okay, 6.4, our tangent ratio. So remembering our triangle toolkit, we have our Pythagorean theorem, so A, B, and C, where C is our hypotenuse and A and B are our legs. We've already gone through our sine ratio, which is opposite divided by hypotenuse, the cosine ratio, which is adjacent divided by hypotenuse. Today we're going to go through tangent ratio, which is our opposite side divided by our adjacent. So if this is our angle, here's opposite, here's adjacent, we're going to be looking at that ratio. So just drawing ourselves a quick look. So if we're going to look at, let's look at this angle. So if we're looking at this angle, I'm doing my opposite side divided by my adjacent side. So here's my hypotenuse. So I'll be doing opposite divided by adjacent to find my tan. Now we're going to use a calculator. We are going to determine the following tangent ratios, and we're going to round those to 4 decimal places. So just like we've been doing with sine and cos. So grabbing your calculator out, tan of 25, making sure you're in degrees mode. So tan of 25 is 0.4663. Okay. Tan of 74 is a 3.4874. Now, this is the first time that we have gotten a number that is over 1. Now, why sine and cos did not have a ratio over 1, is if we take a look, sine ratio is opposite divided by hypotenuse. Now, our hypotenuse is always going to be our largest or longest side. So anytime you're dividing the opposite divided by the hypotenuse, you're always going to have a smaller number divided by a bigger number. So you're always going to get a number that's less than 1. Same thing with cosine. So cosine is adjacent over hypotenuse. So a smaller number divided by a bigger number. And you're always going to be less than 1 there as well. So tangent, we can have numbers that are less than 1 and numbers that are more than 1. So tan of 37. So tan of 37 at 0.753, then we have to round this 5 up to a 6, so 0.7536. And lastly, tan of 89, put it into your calculator and get 57.28996. So I'm going to write this out. So 57.28996. So if I'm going to round that to 4 decimals, take a peek over, this 9 has to round up to a 10. Okay, which means this 9 is rounding up to a 10, which means this 8 is rounding up to a 9. So this equals 57.29, then 0, 0, the 4 decimal places. Okay. So if you think about what this means, so 57.3-ish, this means that when I have tan of 89, so if this angle is the angle that I'm looking at, it is 89 degrees. My opposite side is 57 times larger than my adjacent side. That's right. Okay. So calculating the missing side lengths, round to 1 decimal place. So once again, remember our steps. First step is to label our triangle. So here's my angle, here's my opposite side, here's my hypotenuse across from my right angle, and my adjacent side. Next step, circle 3. 2 things that I know, and 1 thing that I am going to find. So I know this angle, I know this adjacent side, and I want to find the opposite side. So adjacent and opposite, or opposite and adjacent, I will be using tan, obviously, because this is my tangent lesson. Okay, so tan of my angle is going to be opposite divided by adjacent. So tan of 30. So writing our ratio, then subbing in. So tan of 30 degrees equals my opposite, which is x, divided by my adjacent, which is 10. So we're going to keep treating these like we did in the cosine lesson as proportions. So remember, if I write this as a proportion, I'm solving for x, so I will be dividing by the number across from the x and multiplying the other two together. So x will be tan 30 times 10 divided by 1. X equals. Now don't write tan 30 and then times 10. Write the number first and then tan 30 degrees. Remember, if we write tan 30 and then we multiply that by 10, we'll have to make sure we have brackets in our calculator. It's just easier to write like this. So 10 times tan 30 divided by 1, which just gives us 10 times tan 30, so I didn't write that. So 10 times tan 30. And 30. And 5.7735, so on and so forth. And this will be centimeters. And we're going to round to 1 decimal place. So stopping here, take a peek over the wall, we're going to have to round that 7 up to an 8. So 5.8 centimeters is what x equals. So substituting in, after that, we solved our equation, and then we don't forget our units. Example number 2. First step, label. So here's our angle. So here's my opposite side. Here's my hypotenuse. Here's my adjacent side. Next step, circle 3. So 2 things I know. I know an angle, I know the opposite side, and I'm trying to find the adjacent. So opposite and adjacent, I'm going to be using tan. So tan of B equals my opposite divided by my adjacent. Substituting in, tan of 20, so 20 degrees is B, equals opposite, which is 3.5 centimeters, so 3.5, divided by my adjacent, which I'm trying to find. Turning that into a proportion, here's my x. I'll be dividing by the one across from the x and multiplying the other two together. So 3.5 times 1 divided by tan 20 to find x. So 3.5 times 1, which is just 3.5, divided by tan of 20 degrees. And into your calculator. We get 9.6161, so on and so forth. So 9.616, rounding to 1 decimal place. We get 9.6, and then my units are centimeters. So x equals 9.6 centimeters. Next question. So remember, whenever we have word problems, I'm going to require you to draw a picture and then answer the question with a sentence. So how far from the base of the house is the foot of a ladder if the angle of elevation is 70 degrees and it reaches 15 feet up the side of the house? So first off, drawing our house. Here's my beautiful house. I have a ladder leaning up against the house. Here it is. The angle of elevation, so from the ground up, remember his angle of elevation, is 70 degrees. So I know the ladder reaches 15 feet up the side of the house. So 15 feet. And I want to know how far from the base of the house is the foot of the ladder. So I'm looking for this. Now we have our picture. Here's our triangle. We're going to label. So here is my angle. So here is my opposite side. Here's my hypotenuse. And here's my adjacent side. Now circling 3. 2 things that I know, 1 thing that I don't. So I know this angle, I know this opposite side, and I'm trying to find the adjacent side. So opposite and adjacent using tan. So writing our ratio, tan of our angle is going to be opposite divided by adjacent. So tan of 70 degrees equals opposite, which is 15 feet. So 15 divided by adjacent, which is x. WAM10, let's rewrite as a proportion. So here's what I'm solving for. I'll be dividing by tan 70, multiplying the other two together. So x is going to be 15 times 1, which is just 15, divided by tan of 70 degrees. Into our calculator, and we get 5.4595, so on and so forth. And then feet, rounding to 1 decimal place. I'm going to have to round this 4 up to a 5, so this will be 5.5. Okay. So the ladder is 5.5 feet from the base of the house. Next question. We have a lifeguard sitting in a chair that's 2.5 meters high. Okay. Here's my lifeguard. Here's the stairs up to his chair. Here's his chair. And here's him. Or her. Him. So 2.5 meters high is this chair. So he spots a child in the water that is in trouble at an angle of depression of 23 degrees. So remember, angle of depression is he's looking out horizontally and then he looks down at the kid. Okay, so angle of depression is horizontal down. So this angle right here is 23 degrees. And then if I remember my stuff from last unit, if this is 23 degrees, here's two parallel lines. Alternate interior, this will also be 23 degrees. So let's use that one, because I like this triangle better. So 23 degrees is there. And I want to know how far out from the chair, this should be from the base of the chair, is the child. So looking for this. So labeling. So I'm going to be using this triangle here. So here's my angle. This is my opposite side. Here's my adjacent side and my hypotenuse. So circling 3, 2 things I know, 1 thing I don't. So I know the opposite side, I know this angle, and I'm looking for the adjacent. So opposite and adjacent, I'm using tangent. So tan of my angle is opposite divided by adjacent. Substituting in, tan of 23 is my opposite side, so 2.5 meters, 2.5, divided by my adjacent side, which is x. Turning that into proportion, solving for this one, I will divide by tan 23 and multiply these two together. So x will equal 2.5 times 1, which is 2.5, divided by tan of 23. So 2.5 divided by tan 23, calculate, and you get 5.8896, so on and so forth, meters. And rounding to just 1 decimal place. Stop here, take a peek over it. We're going to have to round this up to 5.9. Okay. So the child is 5.9 meters from the base of the chair. Okay, that's our last example, so you can go on to your assignment.